Hello, this is Dr. Anada Sab again, and I'm going briefly to go over the concept of angular momentum, and then I'm going to use the ice skater scratch spin as an example. So, what is angular momentum? Angular momentum is actually the momentum involved in spinning and circling. Is the quantity of motion used with objects rotating about a fixed axis and has the symbol L in the unit kilogram times mass squared divided by second. So the angular momentum is mass times velocity times radius. So what is radius here? So if we take this ice skater here, spinning around the axis of rotation, and then those are the different radiuses along the axis of rotation. And then he's spinning on his toes here, so there's a friction involved here, so less friction in this position. Let's then watch a short video to see exactly how the ice skaters do this. 2 minutes, 662. Okay. First of all, we notice that there is a relationship. So the closer her arms and her legs to her body, the faster she goes. And then it's an angular momentum because she is spinning, circling. And then she's an isolated system because no external force is acting on her. She's doing everything by herself from beginning to end. There's no external force affecting her spinning. So because no outside force acting on her, so we can see that her angular momentum is conserved. So her angular momentum is the same from beginning to end. And then again, this is the formula for it. Mass times velocity times radius. Okay, so to make the momentum big, we need to play with these terms. So of course we can change her mass. Then it has something to do with the velocity and the radius. Okay, at the beginning, if you notice here, she extended her arms and her legs to have a large R. Okay, and then she gains as much speed as possible. Okay, so she's trying to increase this and increase this so she can have a large momentum at the beginning to start with. Let's talk numbers here. Just let's assume that her mass is 50 kilogram and she is rotating to around it per second, which is like pretty slow at the beginning, and then her radius here is 1 meter. We're just assuming those numbers. And then if we calculate the angular momentum, then we have to multiply those numbers together, and then we come up with 100. So I'm gonna just leave the unit for now. I'm gonna just talk numbers to make it easy. So during her spins, there is a conservation of momentum. So assume like the momentum is 100 at the beginning. That's what she gained. She gonna keep this all the way to the end. So in the middle it is 100, and then at the end it's 100. So the only thing that she did different here is she reduces the R, her R. So toward here, if the radius is 0, let's assume that the radius now is 0.5 meters, and then here it's even less. Let's assume it's 0.25 meters. So if we do the calculation, we come up with this. So when the momentum is conserved, the 100, 0.5 meter, the radius here, we can calculate her speed. So when she pulls her arms in, then her speed will be 4. So it doubled between 2 rounds per second to 4 rounds per second here. Okay. And then when she also reduces the R more, let's say like she pulls her arms even more here, then the speed will increase. Okay, if we do the calculation here all the way to the end, then we find that the speed is now 8 rounds per second. So her speed doubled when she folds her arm one. It's a pretty logic and it's math, because if you divide this by 2, then this will automatically multiply it by 2 to keep this one as a constant. Okay, so the conservation of momentum summary. So her momentum stayed 100 until the end. Her mass will not change. If I decreases, then velocity must increase, and this is what she did. The closer her arms, her legs to her body, that means the radius decreases, and then she will automatically spin faster. That same concept applies to Earth. So Earth moves faster when it's closer to the sun. Why? There's also conservation of momentum here. When Earth is closer to the sun, then the radius is smaller, then the Earth will automatically, naturally spin faster. Okay, so conservation of momentum summary. Earth is spinning. Angular momentum was the Earth is an isolated system. We have conservation of momentum. Earth has always the same mass, so if r decreases, that means the velocity must increase. So if r decreases, that means the velocity must increase. So I hope that this helps. Thank you.